Hey, my tech friends, thanks for stopping by. Please like and subscribe if you haven't already. Let's continue to grow this channel. Hope you guys enjoy this video. Hey guys, welcome back to another Ghost 10 system. So, I figured on this particular system what we would do is we would install some packages and see how it works as a daily driver. Before I get into that, what I intend to do is reconnect this thing out to the outside world and run a Wireshark scan. So we can take a look to see specifically what packets are communicating back to the system. I know that somebody had made a comment in one of the other videos about possibly showing a Wireshark scan to see if we could see any traffic going to and from the operating system, which I agree is probably a great way to show what we have as far as a communication between this system and the outside world. With that being said, Windows 10 and Windows 11 are noisy to begin with. So before we start to do a Wireshark scan specifically for this system, we're going to do a Wireshark scan for a Windows 10 out-of-the-box system. So that way we can do the comparison between the logs of both systems. Because generally speaking, if we have a OEM Windows 10 machine and we have the same amount of noise on that OEM Windows 10 machine as we do on our Ghost 10 version, then we know that there's no additional traffic that's being sent or requested to the actual operating system. Now, it's possible that these Ghost toolboxes and additional things that are installed on here will probably need communication for update purposes. And if that's the case, then we may see traffic from those particular applications. That should be relatively simple for us to see through the PID numbers on the actual operating system, as well as the details that are inside the Wireshark PCAP. So it's likely that we may see additional traffic on the system, but that's not considered what I would call nefarious traffic or vindictive traffic or any kind of questionable traffic on this particular operating system. So let's get our Wireshark system scanning on just a base Windows 10 system, and let's take a look at those logs before we jump back into this system. So I want to give a special thanks out to a subscriber that we have. His name is Big Dom. If you see his comment, give him a thumbs up. It's under our Ghost video for 22H2 update. Specifically what he does is he provides us with the details what we have to search for in order to do a in-place upgrade to 22H2 or an upgrade from the actual Ghost Scepter provider. I intend to look into that at some point where we can see if we can do another upgrade to 22H2 from our 20H2 system, specifically to see if we could figure out how to keep the small size but update the operating system to the latest build. So again, big shout out, big special thank you to specifically Big Dom 1002 in the comments section, one of our subscribers. So guys, I wanted to go into what we're going to do on this particular video. We're going to actually roll back to our security configuration and check an additional setting. Now, I already have knowledge of this information by looking at my firewall configurations before I actually do the videos. However, being that my firewall configurations have custom VLANs, routes, and all that other stuff, and I really don't want that publicly available on the internet, no offense. What I do want to give you guys is clarification or transparency into the actual configurations. So what I intend to do is we're going to spin up a Windows 10 machine, just a vanilla Windows 10 machine with no anything on it, just basically out of the box, Windows updates ran, latest version, and we're going to run a Wireshark packet capture against that particular system with it facing the internet, and then we're going to run a second one with it not facing the internet, and we're going to look at the PCAP, the captures for the actual packets to see what we have going on. And then we're going to take that information and we're going to compare it to this Ghost 10 system between it being internal as well as when it has an external connection to see what kind of communication we have going on. Now, my firewall logs already indicate that this particular system doesn't have anything of questionable nature trying to communicate out to the internet. And the reason I say it like that is because we do have packages installed on this particular system that in themselves are reaching out to the internet to look for updated packages, updated components. There's automation involved. And that's the way it should be. So I don't see anything that's wrong with having an automation set up for automatic updates for particular packages to gather updates. Obviously, we have our Windows updates turned off until a certain time on the system, which we shouldn't see Windows updates, checking for updates. However, I did notice in the registry where we have those changes, we also have the addition in there that the search for additional Windows components updates is not disabled. So even though Windows Updates Core is disabled, it's possible that on Windows 10 we may get package update requests. For instance, our Microsoft Edge browser, even though it's not installed, the update service is still running. And to that, we could give a special thanks to one of our additional subscribers. His name is Maximosh. It's Maximosh. Cheers, brother. Yeah, I didn't see a point in the last video to do our change on our configuration to disable our Edge browser, because I just assumed we were going to get the Edge browser reinstalled when we upgraded to 22H2 anyway. But yes, so in the Windows Update configuration on this particular system, we do have the additional package installation set up to install Windows component updates, even though Windows updates are not enabled. So when it connects to the internet, chances are anything that's Microsoft related, it'll still try to update from the apps catalog. So we'll see that inside of the operating systems we re-add it to the network, and when we have our Wireshark running, we'll probably see those requests for package updates. Those are all totally normal things. I don't think that there's anything wrong with the operating system attempting to do that, so I don't report that as anything that's questionable in nature. But let's take a look if there's anything else that's going on, so that way, for the sake of transparency, you guys could see that the operating system doesn't show any remote attempts. Okay, so the first thing we're going to do is we're going to take a look specifically here at our listening configuration on this particular Spectre 10 machine. And these are going to be our process identifiers, which we've discussed in other videos, but for the sake of this video, we can see the process identifiers. These are the ports that the particular system here is listening on. Now, keep in mind, listening is not broadcast, so technically we could have UDP broadcast from the system reporting back to a mothership, more or less, which we wouldn't see as a listening port. Now, a listening port is only going to show connection inbound. So these are the connection ports inbound that are open, that are listening, and these are the process identifiers these systems are listening on. Now, if we go over to the actual task manager, we will see service host, and we'll see 904. We'll see running, and then we'll see that the username is network service. We'll see that we're using about 4 megs of connection here. And then we're going to see UAC virtualization is not allowed. So what is service host, right? What's the SVC host actually doing? That's when we come down here into this other command prompt, and we could check our task list SVC, and then you'll do find /I. Now, /I is not in. However, it's a string value that basically what it does is it tells the system to look for a specific variable that's not going to be case sensitive in the information that you're searching for. So like you're going to find something within here in a string value that says 904 is not a case sensitive or a case contingent variable. I know that that doesn't mean in. In a previous video, I said find in, and quite frankly, that's the easiest way to explain that to people that are doing this for the first time than it is to go into the whole detail on the string value. So I get it. Terminology based off of what the inventor comes up with and what's easily rememberable or memorable is usually not the same thing. For instance, when I ask you what a .gif file is, I'm going to get both GIF and GIF. Now, according to the developer, it's GIF, but anybody that has seen that since the Windows 95 days is going to call it a GIF file because that's what we all called it. So it doesn't necessarily mean that, one is more right than the other. It just means that, the developer might have had this idea that they're going to come up with their terminology for the particular file. But if the popularity of the actual usage of the file dictates that the name changes, then generally the name changes. I mean, if we look at, Microsoft's attempt to go from terminal services to remote desktop services, I don't really know anybody that calls it an RDS system. The majority of people still call it terminal services. And if you look into the configuration on Windows 10, I mean, even in a run configuration, when you type in MSTSC, which is Microsoft Terminal Services Console, we're not typing MSRDS. So even Microsoft never really fully committed to the change of the name. So that's a clarification on what that -I is. But for the sake of this, now we could look under here and we could see the SVC host. We see the PID, or the process identifier of 904, which matches the number up here. And then right here is our configuration. This is what's actually listening on that port. So we could see we have the RPC EPT mapper and then the RPC SS. So at that point, if you need to figure out what those things are where you don't know them and you need to know specifically what that service host is, you could Google these names and it'll tell you specifically what is listening on those particular ports up here. And that's how you troubleshoot this to figure out if you have anything bizarre. Now, another thing to keep in mind, which we have touched base on in a previous video, is the PID numbers themselves. And the reason why is because if we look at the PID numbers, we're going to see low numbers like 92, like 4, 0. And then as we continue to grow in numeric value here, we're seeing what the operating system is loading when the operating system is booting. So when we start to get PID numbers that are in these 6,000s, chances are either it's a process that resets itself, in other words, it recycles itself over time, and that number changes to a higher number because the lower number is not available anymore. It's been used already or currently locked by the process. So when we see this, what these numbers mean is, like, if you ever get, say, God forbid, you get hit with ransomware, or you get hit with something that's a Trojan, usually those applications are going to start up with Windows. So typically speaking, what you'll see is you'll see the system start itself first, then maybe the registry will start itself first, and then you'll see something funky in here in a low PID number. And the reason why is because that application is starting with Windows. But generally speaking, these super low numbers are always going to be your system variables, and always going to be legit. And the reason why is because that's your kernel, that's the operating system that has to load first before it can actually launch the startup processes, which is going to be after your registry. So you'll see things like your Trojan horse start, like your fifth thing down. And the reason why is because it's waiting for the operating system to start. Then it's loading the virus or the malware. And then it loads the rest of the operating system on top of that. Because you don't want the malware to load after the operating system, because then you may miss important details about the operating system. If you're, somebody that wants to, say, hack into a system, you have a Trojan, a worm, ransomware. You want to encrypt those data files before the rest of the operating system starts. So that's why it's important to know your task manager or your task list service console here, so you can actually see this. Now, if you wanted to see everything, you could literally just run this without the find statement in here, and you could get all of the process identifiers back, and you'll see all of your service hosts listed here with what is specifically under each one of these service hosts, what's running, and then the PID number that associates with the actual service host that's running. So these are things that you could definitely check out on your own Windows system while we're going through this video, if you're just curious what you have running or listening on your system. Now, generally speaking, these port numbers that we see up here are also going to have configuration in your Windows firewall. They're going to be opened and allowed through. And if you need to figure out what those are, you should be able to go in there and look specifically for your port numbers. And it should tell you what you have as far as listening and what's listening, or what's written as listening. Sometimes you're going to see something that just straight out says unknown. And if that's the case, sometimes you could Google these port numbers. But keep in mind that in Windows, really Windows 7 through the current Windows operating system, we're going to have something called dynamic port mapping. And what that means is Windows will change the listening port every time you boot the system. And what it's doing in doing that is it's trying to be smart. Basically, it's trying to set a listening port in a dynamic range to allow a connection on a different port each time for security purposes. These are totally normal scenarios in a Windows 10 and a Windows 11 system. Windows 7, 8, 8.1 didn't use it to the extent that Windows 10 and 11 use it. So you're probably not going to see things like this in Windows 7, 8, and 8.1, but Windows 10 and 11, we're going to see these port changes. So the reason why I'm going over this is because now we're going to start to look into the Wireshark configuration on a standard Windows 10 system. And to better understand what we're seeing in the traffic, it's good to understand specifically how this all works, how this all ties in. Because if not, when we go through the process of actually scanning our Wireshark configuration to seeing specifically what we have listening, what we have broadcasting, what we have connecting, if you don't know how the back end of the operating system is translating that information, then looking at the details of your traffic, it's really not going to do much for you. So let's take a look specifically at our Wireshark to see what we have. Actually, before we do that, let's take a look at our bog stock out of the box Windows 10 configuration and see how that varies from what we're seeing here, or if there is any variable in what we're seeing here. And then let's take a look at our Wireshark and let's run some PCAPs, and we'll analyze the traffic based off of the Wireshark outputs based on what we're seeing in these two systems. Okay, so before we move on to our Pwn stock Windows 10 system, I do want to do one more thing in here. I want to go through Task Manager real quick and specifically look at the username configuration. And again, we're still on our Ghost system. So if we go in here and we look, we're going to see local service. We're going to see DWM-1. We're going to see network service. We're going to see system. And we're going to see my username that's currently logged into the system. So these are things that are going to load specifically with the profile. So if you end up in a situation where you have a virus, but it's only associated to this particular username you're logged into, then chances are it's a user-based configured virus that only affects your profile. So if you log on with a second profile, you could check to see if that particular application starts with your profile. And if it doesn't, then you know that likely it's something that you specifically did and not somebody else that was on your machine, which is why it's so important to use different profiles when you're in a business situation where you log into a system. You don't want somebody else using your username to log in, because in the IT world, for somebody like myself or somebody else to come in, if two people share the same user account when they log into the system and one person installs, say, a crypto miner on purpose on the system, then there's no way to tell outside of using time clock. So if it happens at 3 o'clock, but one person's shift ends at 3 o'clock and the other one starts at 3 o'clock, then generally speaking, it's the first person that was in the office. It's their fault versus the person that just came in. And that's just the way it works in the security realm in the IT field, typically, unless there's cameras, and then you could check for that specific time. But usually that's why it's important to make sure that you have your own username when you log into a system, especially a system that's shared. That said, when we look at this, if we look at our usernames, for instance, I don't know what DWM-1 is in this situation. I mean, I do, but for the sake of this video, let's say I don't know what this user account is in this situation. And I want to know if this actual application is something that's not healthy to have on a system, right? Is this a virus? The easiest way to tell is we could just right-click on this, and we could go to Properties. And once we're in Properties, if you go to Details, you'll see the copyright information of the actual application. You'll see the product name. You'll see the file description. You'll see whether it's an application. You'll see the size. You'll see the date modified. You'll see the original file name. And specifically, really what you're looking for is the copyright. So if we know that it's copyrighted from the Microsoft Corporation, then we know that it came from Microsoft. It's part of the operating system. So it's something you don't have to really worry about at that point. Because typically speaking, when you have a file that's copied, so another file called, say, dwm.exe, that's a malware or a Trojan that's pretending to be the Microsoft version, they usually don't have the copyright information correctly written. They usually don't have the product name correctly written. They usually don't have a product version. Usually this details pane would be empty. There would be some information, but probably not the right information. You may see stuff that's screwed up. You're not going to see the little copyright information. This usually will tell you, and I say usually because sometimes people will take the time to actually make it look very, very convincing, but 99% of the time they don't. So if you have questions, you could literally just right-click on the application, choose Properties, choose the Details tab, and check to see specifically what your product and information is in there if you're curious as to whether or not that's a legit process running on your operating system. All right, so let's go back now to that other Windows 10 machine. Let's take a look, see specifically what we got going on there. Okay guys, so we're back on our Windows 10 out-of-the-box configuration. And immediately we're going to notice that our listening list, our list of actual ports that we're listening on, is longer than it is on our Ghost 7 machine. So we know about the 4,000, the 49,664 through 670 from a variety of previous videos when we went through the actual product identifiers for these particular services, and found that for the vast majority of them anyway, they are legit. Some of them are a little suspect, a little bizarre, but they are Microsoft-based services. They're just some of them are introduced in 22H2 for Windows 10, and will become common and norm in Windows 11. But that said, that's part of that dynamic port mapping. That's normal. This is our NetBIOS connection for port 139. Again, port 139. That's normal. Keep in mind that there are security concerns about NetBIOS communication in Windows 10 and 11, and in a domain computer or domain configuration, generally speaking, with group policy, those are things that you want to shut off if you don't have older systems on your infrastructure, is NetBIOS should be disabled. But for the sake of an out-of-box machine, that's totally normal. Then we have port 7680 here, which is specifically listening on PID or process identifier 4424. So if we scroll down in here, we can take a look to see specifically what that is. And we'll see that's hidden again under a service host. So it's 4424. Let's see. So it's DOSVC. So basically what DOSVC is it's the new version of BITS, which is a protocol or configuration application made by Microsoft to accelerate the download speed of certain Microsoft-based products. So for instance, your Windows updates, to download them faster, this particular service runs to download your updates faster. So we don't see this on the Ghost system because we have that registry modification not to allow the updates until like 2039 or whatever the heck that configuration was on that system. So that's one thing that we trimmed out of the other operating system. Then we have 5040. So if we go back over here and take a look at 5040, well, it doesn't look, oh, I'm looking at the wrong thing. I apologize. Specifically 4304 is the process identifier. Another service host, so basically just up arrow. So for that, we have the CDP service, or CDP SVC. I think we've talked about this particular service in the past, but specifically what this thing does is it allows a secure communication between third-party devices and your Windows operating system. So for instance, when you connect it to like an Xbox, that service will run. When you connect it to like your Android phone or your iPhone to send like messages through your system, that service will run. It's used for the authentication process for non-Windows based operating systems to communicate directly to a Windows system. It allows a secure encrypted connection between the devices. So, all right, let's continue on. Okay, guys, so welcome over to our Wireshark system. Now, this particular system is on the same subnet as the Ghost system, as well as our OEM Windows 10 machine. So this particular system has an IP address of 192.168.242.215. The IP address of our OEM system, which is listed inside of our host area here, is 192.168.242.219. Now that's the system that is out of the box ISO configured Windows 10. And what we're going to do is we're actually going to do a capture on that particular host IP address. So we'll start our capture here. And we're going to see broadcast because we're specifically looking for our DNS server right now, but we don't have DNS enabled on our internal network. So we're going to just see a bunch of ARP broadcasts, specifically trying to figure out who the particular IP address is for a particular system. Now that 219, once again, is going to be our Windows 10 OEM system. So what we're going to do is we're actually going to start a ping to see if we could see any of the ping responses appear. And my best guess is that we will see that, but we don't see anything right now, at least going towards or from that system outside of just DNS lookups to figure out specifically who that system is. So let's generate a little traffic. So there we go. We see the ICMP requests. And the reason why we're not getting any response is because I have the Windows firewall turned on our OEM machine, right? So it's out of the box. And as a result, we're just not going to get any responses because, you know, it's blocking ICMP basically. The relay won't work. Also, on this particular system, I have the firewall enabled for ICMP and a variety of other stuff just so we could get additional traffic. I don't want anything to get blocked on our Wireshark system. So with that said, we know that our particular capture is working on this particular system, and we don't have anything coming back or through. So we know that the Windows 10 machine at least isn't attempting to broadcast to the internet when it is not on an external facing interface. So let's take a look now and add that machine to our external interface, and then we will run this capture again on the external network to see specifically if we see any traffic going from that machine to the internet. Now I'm going to guess that we will. We'll probably see things for Windows updates and things of that nature. So let's kick this off again once we get this machine on the public side. Okay guys, so I ran a capture for about 10-12 minutes while we were connected to the internet from both our OEM system as well as our Wireshark system. And they were on their own subnet, connected directly to the net. During my capture, the only things we really see in here is the SSDP broadcast protocol, which is an advertising protocol that's built into the Microsoft Edge service and built into Microsoft Windows. That's the only broadcast we see from our OEM Windows 10 machine. So now let's take a look at the Ghost machine and see specifically if we have the same protocols showing on our Ghost machine. Now, presumably we won't because Edge isn't running on our Ghost machine. We already know that we don't have the same services running or listening on our Ghost machine. So likely we're not going to see these SSDP protocols for Microsoft Edge. Now we might see them for other things because it is an advertising identifier and basically allows Windows to connect on anything. So those generic annoying pop-ups you get in Windows 11, usually it'll show as this SSDP protocol when you're connected to the internet. That's what's generating those pop-ups for your remote connection to the internet, is these particular advertising IDs or identifiers. So let's take a look specifically at our configuration on our Ghost system to see both on a LAN configuration as well as on a WAN configuration what the difference is and if there's any difference at all. Okay guys, so we're back. We have our Ghost system up and running. We have a static IP address of 192.168.242.218, as we can see up here, set for capture on Ethernet. So on this particular system, we have it up. We have the Windows firewall turned on. And we are going to run a scan to see if it's attempting to communicate to anything before we connect it to the public side to see if, once we have it on the public side, if it starts to communicate more or what it starts to communicate. So let's kick this off. So we'll start our capture. And we're going to see a lot of ARP, which is broadcast, which basically, because I don't have DNS currently configured or currently running on this particular subnet, we'll likely see a lot of broadcast for whois, which is basically who's running this because it can't figure out what the host name is based off of DNS lookup. So let's take a look and see what happens if on the Ghost 10 machine we run a ping to this particular system. So there we go. We get our echo reply requests and our responses. And so we know that the connection's working, that it is connected to the network, that it does have network communication. And that tells us basically that our particular system is online for the sake of being online. So we don't see anything being broadcasted from that particular system out to the internal network, trying to communicate to anything outbound, which is good news. That's a good sign. So let's stop this. Let's add that system now to the other subnet. We'll get the Wireshark back on the other subnet. We'll run the same scans against it again with its connection to the internet and see if we get additional traffic, and if so, what traffic, and is it the same as what we get on our OEM Windows 10 machine. Okay guys, so our capture is now running on our Wireshark system, specifically pointing to our Ghost system. The Ghost system has just got the pop-up like we saw in the previous video about getting Microsoft Edge configured on our system. However, we see that we have no traffic. So even though the update service appears to have attempted to update the Edge application, we don't see any traffic from that system yet. So let's do a ping to just make sure our network connection is functioning correctly. Well, there we go. We do have ARP, and we do have the ICMP is coming. So now we're seeing the discovery information for the whois again for the broadcast, because once again, I'm not using DNS on this network. I have it configured right now to point directly to 8.8.8.8, which is the Google DNS and not internal. Just in case, because I don't want internal discovery turned on to find different devices on my internal infrastructure if there's something connecting to it from the outside. They would have to get into it and then at that point run the scan. But we would see that through here. We're filtering all traffic into the system, and as you can see, we got nothing. Let's hang out for a few. I will kick this back off in a bit. Take a look at the time. So we got 10:59 a.m. Friday, March 29th. Let's jump back in here at like 11:10. And see if this has changed. I'll continue to run the filter until then. Okay, guys, so I missed my my point. I got up and stepped away for a couple here, but we're at 11:41 a.m. This particular scan, I stopped, and we could look at the specific time here at about 11:10 a.m. and 7 seconds. That's when I stopped the actual scan. That's the last time this packet came through. If we scroll down here, we're going to see the same msearch, the SSDP service. And specifically, we're going to see the IP address. And then we're going to see the port number. So you'll see the destination. So the source port, that's where it's coming from. The destination port is 1900. So we could jump over to the ghost machine and take a look to see specifically what's listening on port 1900. But it's coming from 239.255.255.250 to port 1900. And specifically, we're getting it from the upnp.org device, Internet Gateway device. So I did a little homework specifically to figure out what this is and where it's coming from. And again, it's an advertisement ID that's being sent to Windows. Now, as for why this service is running on the slimmed down version of Ghost, I'm not sure. Honestly, you could probably just disable it because we don't have the rest of the front end of the operating system that would actually publish this information. So if you jumped into the Ghost system and specifically looked for the SSDP SRV service under the service host and disabled that, you likely wouldn't get these advertisements coming through. And again, there's really no reason to run them because the rest of the operating system isn't intact that would need this in order to run. Now, that said, it may functionally need to be there in order for you to communicate to maybe like Xbox or to communicate with different applications. That's something we could take a look in future videos. But for the sake of this, at least from a capture perspective, there's really nothing here. So, I mean, from a broadcast, a phone home scenario, a check for the mothership, something from the outside trying to remote connect to it, it's clean. I don't see anything on the Nessus scanner to indicate that we have any penetration issues as far as security-related issues on the system. Those all appear to be clean too. So far, the system's doing really good. I would give it, 2 thumbs up so far. Let's see if we can get some applications installed on this thing in our next video. I figured I would just show you guys this real quick before we disconnect, and specifically, that's this, right? So we were curious what we were listening to for the 1900 port. 1900. It's a UDP broadcast port, but we're seeing port 1900 listening for a UDP broadcast port from PID 6736. And if we come up here into our service host configuration, we can see 6736, and then we'll see the SSDP SRV service in here. And if we go down here, we could actually right-click on this and go to services, and we'll find the SSDP service. So if we then open the services console specifically to go to that particular service, and we right click on this bad boy and we go to properties, we could change this to disabled, hit apply and stop it. And at that point, the discovery service isn't going to run. You're not going to get those notifications anymore on your Go system. So that might be something you want to do on your system if you don't need it to run. It may be required, though, if you're running like Microsoft Office and additional products on the actual Go system. But if you're using it just for a browser that's not Microsoft Edge, you should really have no need to actually run that particular discovery service. And once that's disabled, if we go back up in here and we do another search for that 1900, you'll see that there's nothing, right? So we don't have anything listening anymore on the 1900 port. And we could go another step and actually change this to listening. And once again, you'll see that the 1900 is missing. It's gone from our listening ports. So I don't see any reason why this isn't something that you guys could use so far as a daily driver. Again, all things considered, it runs pretty good. It's relatively small. It's very smooth. I haven't had any bugs or any issues, any crashes with it. And at least from our Wireshark communication, our port listening configuration, and our Nesiscan, it looks pretty good so far. So again, thanks for sticking around, and I will catch you guys in the next video.